The next question I'm going to work through an example of is this question 5, the one that's similar to question 5, where you're asked for a position isomer of this carboxylic acid. Your carboxylic acid is ever so slightly different. Let's check. Yours is C4H8O2 and mine just has one extra carbon. So this is a position isomer, which means that this functional group is not going to change. It will maintain the fact that it's a carboxylic acid, but it's going to be somewhere else on this molecule. First of all, I'm just going to copy and paste, and I'm going to get rid of this functional group. So what we have is 1, 2, 3, 4, 5 carbons in a row. 1, 2, 3, 4, 5. We just don't have the oxygens. So a way of doing this, if I remove a carbon from this chain and reposition it, what we can have is our functional group can extend from this branched carbon. And what we will have is we will still have the same number of carbons, the same number of hydrogens, the same number of oxygens in these molecules, but they are reconfigured. They're not the same molecule, and the carboxylic acid group is intact. There it is on that one, there it is on that one. The reason we have moved a carbon from the main chain and branched it downwards is that a carboxylic acid group cannot be positioned on a middle carbon. It's just not possible. You need 3 bonds coming out of this carbon, 2 to the O and 1 to this O, and that's not possible in these middle carbons. They only have 2 free bonds to make. So a carboxylic acid group has to go on an end carbon. If we had put it on this one over here instead of this one here, it's not a different molecule, it's just been turned around. So we have to branch off a middle one and build it off there in order to make this isomer.